So the system that I work on in this video I thought was very interesting because it didn't have a thermostat on it, and I'll just kind of show you what I actually found there while I was working on the system. But then I'll explain how a system like this can actually operate, and I'll actually bring up the temperature pressure chart for this refrigerant so you can kind of understand how the system can even work that way. In this case, the pressure switch had actually gone bad, so that's what I replaced. And then when I was trying to find the thermostat and make sure everything was going to be good to go, I realized that there actually wasn't one. So anyway, I hope that you find it interesting. So I just replaced the pressure switch on this system, and I think that this cooler does not have a thermostat in here at all. See, the line set goes through the floor there. Comes up, obviously liquid line here, suction line here. And look where it goes into the unit. Kind of hard to see through the fan, but I don't see any thermostat up in here at all. The liquid line goes into the suction line right there, makes a loop around, and then it comes back out over here somewhere and goes into the expansion valve right there. Kind of hard to see. I don't think there's any thermostat on this thing at all. So that means our cut-in and cut-out pressures are extremely crucial. So here we are in the basement. That's the line set coming down from upstairs. Comes across and over to this little guy. Now obviously this condenser unit is newer than the cooler. And I just replaced this pressure switch right here. And I left the old one here so that we can reference it. So on this old one, cutout is cut in minus differential. You can see the cut in is set at 40 and the differential is set at 15. So if we subtract 15 from 40, that gives us 25. So that means our cutout is 25 psi, our cut in is 40, and of course that gives us a differential of 15. So it's kind of a confusing way they write this out on here. I have to like say it out loud to myself a couple times to make sure I'm understanding it correctly. But then we look at the new one, and it's a new style where it just has cutout and cut in. So we need cut in to be set right at 40, which I believe it is, and we need cutout to be set right at 25. So if I go too far with this, it'll probably shut off. Kind of want to. Yeah, there we go. So you can see it was very close to shutting off. So I just pushed it up to like 30 and it kicked the unit off. So it just cuts in and cuts out based on that low side pressure. Oh, just cycled back on again. So see, the differential is too short. So we need to turn this back down. Obviously I wasn't going to leave it here, but I didn't want to short cycle the compressor. So we'll turn this back down to 25 and 40, so 15 psi differential. I kind of want it to have a little bit more differential, so maybe we'll turn the 40 just up a little bit more, so it's more like 43, 44. That'll give us more like 18 for the differential. So yeah, 25 and 40. Okay, so I just came down here to the computer to further explain this, but the refrigerant that we're actually using is this R401A, and you can see this is actually the mixture that it is, partly R22, partly R124, R125, so it's a blend of refrigerants, and that's why you always have to charge it as a liquid, because as a liquid all of these are equally dissolved in these different percentages, but if you try to charge it as a vapor, then the lighter refrigerants will come out first. You can only charge as a vapor if it's a pure refrigerant, because in a mix like this it'll evaporate the lighter ones out first. But if we scroll up here, this is the temperature pressure chart. So we're gonna go to the vapor pressure, which is the evaporator temperature. If we scroll down, you can remember we were right at around 25. So that 25 cutout pressure corresponds to about 25 degrees on the evaporator temperature. And then as it warms back up to around 45, I think I left it at like 43 or 44, it's going to have to warm up to about 42 degrees. So with those two cut in and cut out set points on that unit, the walk-in cooler is going to maintain below about 40 degrees. Obviously 42 is above that set point, but he has thermometers in there. I specifically told him to just keep a close eye on it, because if one of those pressures was set too high, then the cooler might run a little bit too warm, and if the pressures were set too low, then that evaporator coil would get too cold and it would freeze up really quickly. I don't think that system had any kind of defrost timer on it, so whoever installed it originally and just used the pressure switch just had to get the settings dialed in just right so that the evaporator wouldn't freeze up and the cooler would stay cold enough, which when I had checked with him, he said it was doing fine, so no concerns there from where we ended up setting the pressure switch. But that's how you can actually set up a system to just run based off of the cut in and cut out pressures on the pressure switch, and you actually don't need a thermostat when you do that. So kind of an old style of refrigeration. I don't see like any of these systems out there anymore. Obviously there's a few that still exist, but everything that we put in nowadays has an additional thermostat along with the pressure switch, so that they can just use the thermostat to cycle it on and off, usually cycling that liquid line solenoid coil. There are times too where they actually directly shut off the power going to the compressor and the system doesn't pump down. So lots of different ways that you can do it. Very neat, I think, that you can do it with just a pressure switch and you don't actually need a thermostat. So that's why I wanted to make a video about it, just kind of briefly explaining what is going on with that, because it's pretty unique and pretty cool, and something that I really don't see very often. So anyway, hope that you enjoyed the video, and I will talk to you guys later.